Welcome to Pre-Algebra Section 1-2 Problem Solving Plan. We'll begin our day today with the vocabulary for our topic. The first item, variable, is a symbol that represents an unknown number. We can use any letter of the alphabet. Many times we use the letters X or Y or Z, but there are many other letters that you can use. Our second word is defining a variable. That means we will be picking a variable to represent an unknown number. For example, we will define a variable to represent Mrs. Rasmus's golf score. In this case, we can say G is equal to Mrs. Rasmus golf score. That is defining the variable. When I look at my next vocabulary word, which is domain, that is the possible values that a variable can be. So, for example, when I'm looking at defining my variable for my golf score, then I can look at what are some possible golf scores I could have. So I say G is an element, and the domain could be, if I was on a par 3 course with 9 holes, I could possibly have a score of 27. If I shot a couple under, I could have a possibility of 25. If I had a very poor day, I could have a possibility of 54. Those are three possible answers that could work for my domain, but there could be many answers that would work. We'll move on to our problem-solving plan. When I look at our problem-solving plan, the first thing that we do, one of the most important things, is to read the problem carefully. And when you're reading the problem, you are going to determine what you need to find, or the question, what are they asking. When I read the problem carefully, I normally read it very slowly. And sometimes if it's confusing, I will read it out loud, or I will ask someone to read it out loud for me. My second step is I will define a variable and express all unknowns in terms of that variable. Currently, we will be only using one variable. And when we define it, we will be very specific, just as I showed on the last slide. And we will either pick a person or the thing that we know the least about. Moving on, after we've found all of the unknowns and we have defined them, we'll move on and write an equation. When we write an equation, I like to write it in words, and then I write it using symbols. Many times it could be something like this. Tom plus Joe is equal to 73. That is what I'm talking about, writing it in words. Then if I was to write it in symbols, maybe I would have this as my symbols to be able to write that out. I will show a specific example today after we finish our problem solving plan. Number 4, we'll solve the equation. So once we have our equation here, we'll follow our steps to solve it. And then finally, our last thing, we will write the answer. We'll write it in a short sentence, and we will always include any units that are necessary. We'll move on to our examples, and we'll apply the problem solving plan. Our first example is this. Mrs. Hanson has 6 more students than Mrs. Rasmus. Together they have 36 students. How many students does each have? So the first thing I'm going to look for are the unknowns. So I see that I do not know about Mrs. Hanson, how many students she has, and I do not know about Mrs. Rasmus's students and how many she has. So I've listed my unknowns. After I read through the sentence again, Mrs. Hanson has 6 more students than Mrs. Rasmus. I note that Mrs. Rasmus, I know very little information, so I'm going to call that X. Whereas with Mrs. Hanson, I know that she has 6 more students. So 6 more means I'll take what Mrs. Rasmus has and add 6 to it. I have now defined all of my variables and linked them to the unknowns. I'll read the second sentence. Together they have 36 students. So that tells me that if I take Rasmus students and add in Hansen students, I will get a total. Well, using the information that I have defined and also from the problem, Rasmus represents x, Hansen is x plus 6, and the total is 36. I now have my equation. I will now solve it. I'll combine my two like terms, so 2x plus 6 is equal to 36. I will subtract 6 from both sides. 2x is equal to 30. And I will divide by 2 on both sides, leaving me with x is equal to 15. I now can take that answer and come back up here to where I defined items. Mrs. Rasmus has 15 students, where Mrs. Hansen has 15 plus 6 students, so I know that Mrs. Hansen has 21 students. To write my answer, I would say Mrs. Hansen has 21 students and Mrs. Rasmus has 15 students. And that will complete that problem. We can also check to make sure 21 plus 15 is 36, and I do see that we have a total of 36, so yes, my answer is correct. Moving on to our last example. Mrs. Southworth walked 4 miles per hour faster than Ms. Schemberger. Ms. Southworth walked twice as fast as Mrs. Schemberger. How fast did each person walk? Once again, I will list the unknowns. So I have Schemberger, miles per hour, and I have Southworth, miles per hour. Those are my two unknowns. When I read my first and second sentence, I notice that we know something about Miss Southworth in both of those. She's either walking faster than Miss Schemberger by 4 miles an hour or twice as fast as Miss Schemberger. So that tells me Schemberger is the one that I know the least amount, so I'm going to call Schemberger as x. Using the first sentence, Southworth walks 4 miles faster, so I go x plus 4. And when I read the second sentence, I notice that she walks twice as fast as Schemberger. So now, after I've defined my variables, I notice that I have two that are the same. They both represent Southworth. These are the same. And in math class, when we have same, that means that they are equal. So that means that I'm rewriting Southworth's miles per hour in two different forms. One as an addition problem and one as a multiplication problem. Since they are equal, I can write my equation 4x is equal to 2x. And then I can solve. I'm going to subtract 1x from both sides. When I subtract 1x from both sides, I end up with 4 is equal to x. Now, I know that 4 is equal to x. That tells me that Ms. Schemberger walks 4 miles per hour. And Ms. Southworth walks either 2 times 4, which is 8, or 4 plus 4, which is 8. So my answer would be Mrs. Southworth walks 8 miles per hour, more like a run, and Mrs. Schemberger walks 4 miles per hour. that concludes this lesson.